Hello and welcome back, and that is right, today it is the turn of reviewing the XPG Gammix S70 Blade model. A number of you, around about a month ago when I reviewed this, the Gammix S70, were very keen to highlight that as good as that model was, at least in my opinion, and its big fat heatsink that we will be talking about later, a lot of you were a lot more interested in this with the light and the camera going nuts. This is the Blade version of that SSD with incredibly similar architecture, but with a few tweaks along the way that I will talk about, as well as being considerably thinner in stature. Even the retail box is smaller. And in today's video, I'm going to talk for a lot of the specifications, talk about what I like, some of the things I'm less keen on, get it on the test machine and go through some of that testing. And of course, we'll be looking about how it compares with its larger version, that big fat heatsink version, the non-Blade, as I'm going to call it in this video. But without going, without going into too specific, let's keep it light, early doors. Let's talk about the price point, because a number of you are looking at this SSD, because despite it arriving with a significantly high performance at sequential read at well over 7,000, hitting maximums of 7,400 megabytes per second, probably one of the closest SSDs we've seen to fully saturating PCIe Gen 4x4 M2 NVMe bandwidth, and with write performance getting incredibly close at 6,700 at the highest capacity. This drive, weirdly, is actually surprisingly cheap. Cheap might not be the right word. It's, not gutter barrel price. But once you compare it against your WD Blacks, your Samsung 980s, your 5 CUDA 530s, and your Sprint Rockets, this is really affordable compared to those, despite its performance benchmarks wildly exceeding most of those. So the lowest capacity at 500 gig, knocking around for about $99. The 1TB at $149, and the 2TB at an impressive $299, which again isn't a small bit of money, and you can pick up some PCIe Gen 4x4 SSDs at 2TB for about $240 to $250, but a lot of those are like Phison E18 and they're like 5,000 megs throughput. This is one of the fastest SSDs in the market in the right PC, of course, but arriving at a price point considerably lower than many of the alternative drives out there that exceed into the £300 and even the £400 margins there. So that's the retail box there, that really shiny box that I hate because it makes the lighting in the studio go nuts. Let's have a look at the drive itself, because another thing about this drive that a lot of you are interested in, much like the non-Blade version, this arrives with a thermal extra built in. So you've got the SSD there with no cover on board. You've got here, this is the 1TB model, which is dual ranked on this 1TB. It's got 4 NAND chips there, each with 256 gigabytes on board. So that's your 1TB across 4 NAND chips. We'll talk about that in a moment. But it also arrives with this incredibly thin thermal plate. It is metal, it's not like a kind of foil alloy there. And it's got a thermal pad on the back that's adhesive based. You peel that off and then you can attach that to this drive, something we will be doing later on before we put it inside the test machine. But that means that even with this heat dissipating thermal panel here, and we get that on there and I will stick it on shortly, that is how tall this drive is with that panel on board. Just to put that into perspective, this is the heatsink that the other one arrived with an enormous difference in height between them. And again, if you have been looking at the XPG series for installation in a PS5, a number of you no doubt are aware that the slot these SSDs go into is remarkably small. And a lot of SSDs with chunkier heatsinks, and again, I include the XPG Gammix, I include the Sabran non-PS5 designed heatsink there. These are too big for that slot. So in order to attach decent heat dissipation on them, because a lot of heat is going into those components, particularly that one at the end, the controller, this metal panel is designed with the thermal pads to basically absorb all of the heat from those controller components, I hate seagulls, and then sort of disperse it into the air. But the PS5 uses something called negative pressure, where that there's a vent on the front and the back that's drawing air in one way and pushing it out the other. And there's fears by some that if you have an SSD inside that system without the PS5's cover plate on top, it can interfere with that pressure as air is passing through the PlayStation and through the components. Is it then going to interrupt that flow with this big heatsink that, although will ensure the drive stays lovely and cool as it dissipates the heat into the air, but does the blocking of that airflow now impede other important components in the PlayStation's cooling system there? So a lot of you, when looking at the XPG series for your PS5, because XPG is a big name in gaming accessories, peripherals and hardware upgrades, is it worth ditching this big fat heatsink and going for the more contained, more affordable and certainly more petite thermal plate there on the top? So again, that's a lot of stuff we're going to be looking at. And yes, we've already started PS5 testing. I believe the PS5 testing on this has gone live. We've got a versus video where we look at both the temperature and the performance of the XPG fat heatsink versus the thermal plate there on the Blade. But that's enough of that for now with a comparison. Let's talk a lot about this SSD itself. Now, it arrives with the Innogrit controller we talked about before, the IG5236. And again, in a marketplace that is being heavily dominated by Gen 4 SSDs that take advantage of that Phison E18 controller, which is a very good controller. Let's be straight about this. It's a great controller. However, with everyone utilizing it, that's a lot of power being by one manufacturer of component chips. Now, companies like Samsung and WD use in-house manufacture for if not most of their components. But then you've got Innogrit with their first PS4 controller, which even in early testing surpassed sequential read and write in a number of tests than that Phison E18. And much like the Patriot Viper and indeed the non-Blade version of this Adata SSD, this SSD arrives with this Innogrit controller there on board, and we will talk a little bit about durability, IOPS and throughput very shortly. Alongside that, you've got DDR4 SD RAM there on board, and again that's 512 meg 1 GB and 2 GB on the 500 gig 1 TB and 2 TB respectively there. The NAND is lovely to see here for two reasons. One, as mentioned, it's taking advantage of being 4 NAND cells rather than 2, which can often make things more expensive at the point of manufacture, but can improve performance and kind of assist anti-wear on the drive internally with the right operations. But this NAND not only being 3D TLC NAND, which is what we would expect, but it's 176 layer NAND as well. So not only is that better than the majority of SSDs out there, where more than 90% of them are using 96 layer NAND with a few exceptions, on top of that, this has got that 176 layer 3D TLC NAND, whereas the fat version arrives with 96 layer NAND. Now, may be upgrading that in production for later versions, but there's still no denying it. It's nice that you've got that extra layer of NAND protection there on board. And by protection, of course, what I mean is this SSD also arrives with a higher durability than a number of its contemporaries out there. More than 80 to 90% of NVMe PCIe Gen 4 SSDs in the market take advantage of drive writes per day of 0.3 as their durability. That's the amount that they can be written to. It's a kind of decimal or percentage form per day based on their capacity. This drive arrives at 0.38 to 0.4 drive writes per day, which I know doesn't seem like much, but given that it's lower in price than most of the other SSDs out there in the same bracket and includes that thermal plate on the top, that's still pretty impressive, with the terabytes written on each capacity at 370, 740 and 1480 terabytes written across all three capacities. Now, in terms of its overall performance, we can talk a little bit there about sequential read and write. So that's the big data back and forth onto it. Again, very much you gamers want to hear of this. Across the board, Read performance of sequential read is rated at the maximum of 7,400 at all three capacities, which is great to hear. On the write performance, it does dip. Obviously, the lowest performing one there, which has got 2 NAND cells on board. Unfortunately, it's pretty low at 2,600 sequential write, but at the 1 TB and the 2 TB, it goes up to 5,500 and 6,700 respectively. Again, kind of wish the 1 TB had a little bit more going on given its distribution of 4 NAND cells, but still pretty good. And indeed, it's just a mite lower than what we've seen in the non-Blade version. And during our testing, we will of course be looking at a number of our earlier test results to see how this compares with this when this is using the thermal plate and this SSD was using that big fat heatsink. I'm going to of course look at IOPS and performance to see how they compared on each individual tier. Now, moving away from that big data sequential performance there, we'll talk a little bit about IOPS, particularly 4K IOPS. So this is as many individual input outputs per second possible. So again, those that be running databases or caching are going to be a little bit more concerned with stuff like that. I'm pleased to say this SSD does do quite well, quite high indeed, but at least by the reported manufacturer's benchmarks, we're not seeing any breaking into the 1 mil territory there with 4K read IOPS at 425,000, 740,000 and 740,000 again at the 500 gig 1 TB and 2 TB of 4K read IOPS. In write IOPS, again, the smallest capacity, there's a dip, 510,000, but the 1 TB and the 2 TB keeping it quite high at 740 and 750,000 respectively. So again, great numbers, but that's an area where this SSD seems to drop the ball the tiniest bit. Now, I'm not 100% certain why. The controller is still pretty darn good, and we've seen that controller break the 900,000 and 1 mil in testing in previous SSDs. It's got that 176 layer NAND, it's got that Innogrit controller, which has been proven to hit that mark a number of times. So I'm kind of surprised some of those figures, those reported benchmarks, are a little low. Of course, in our testing, not only will we be running a barrage of different tests and monitoring the temperature, which is going to be really important because we want to know how well, one, this dissipates heat, in other words, how quickly it lowers the temperature, but also what is the height it can reach. If it exceeds 70, I will be very, very disappointed. The other thing worth highlighting is we're going to be looking at the firmware. The Adata XPG series received a firmware update in August, which really did improve performance there. So again, I'm not only going to update the firmware on it, I'm going to include a segment there showing you guys how to update the firmware, because I know in the previous video I told you the firmware was updated and showed you, but I didn't walk you through the process, which is a bit of a sad thing not to do. So I'm going to make sure to include Adata's own application to update that firmware and show you how it's done. But for now, let's make our way over to the test machine, go through those tests and work out not only is this SSD any good, but whether you should go for it or you're better off spending money on the big fat article here. Let's switch over to the screen. Okay, so we've made our way onto the desktop here, and we're going to go ahead and set this drive up for our testing. Normally I would skip the early stages of this, but I think a lot of you might be interested to know just how I set up for this testing. So you can see here on the top right of the screen, Crystal Disk has now acknowledged that it has the S70 Blade 1 TB inside there. We are utilising the S70's own heatsink there, that heat shield there on top, and the heat is already sitting at a higher than normal 38C. Now 38C isn't bad, but I will say as a idle non-access temperature, that's a fraction higher than I would have normally expected compared with at least fatter heat sinks, but I shouldn't really be that surprised. We're utilising OBS for our screen recording here, and let's go ahead and start adding this drive. So first thing we want to do is open up the storage manager. You can do it from within this application if you choose, or you can just go straight into the this PC or my computer area, go into the My Computer tab and select Manage. It will open up the admin panel here for computer management. We go into storage, go into disk management, and right there at the bottom you can see our drive has been acknowledged, and we've just got to initialize the disk. So let's go ahead, make sure it's not an MBR. Go ahead and we'll add that on there, make a nice simple volume, nice and straightforward. We'll give it a letter, give it the letter X, click next, give it a name. We're going to call this one S70 Blade. Do a nice quick format there, And boom, that's our drive that's now going to be accessible and usable on our system there, the whole drive. We can go ahead and from here I can start talking you through some of the tests we're going to be running. So we're using a Windows 10 machine. It's Windows 10 with a 6-core i5 processor. Let's go into the system properties there. As you can see, 11th gen, I should say, i5 6-core processor, 16 gig of memory. We don't have a GPU card installed here, but we are utilizing a Windows 10 Pro machine there, and this should be enough for the majority of our tests. We're not utilizing the drive as a primary OS drive there. We're using it in the additional PCIe Gen 4x4 slot. As you can see, it's utilizing the full transfer mode of 4x4, and it's utilizing NVMe 1.4 as well. So let's go ahead and start lining up for our tests. Now, in the video, we're going to be looking at the following. We're going to be running an initial test on Crystal Disk. I'm sorry if the screen went black for you there. That is because every time I open those up, the admin panel has to get my permission. From that, we can have a look at Atto Disk Benchmark afterwards. Atto Disk, next one we're going to look at there. After Atto, we're going to be looking at SSD. And of course, after that, we're going to be looking at AJA there. Now, it's worth highlighting a couple of things. One, I'll be running 3 tests of different file formats on every one of these programs. Also, I am going to have to turn off OBS during this process as it can affect the performance. I could use an external capture card, but that's currently in use with some PS5 comparative testing right now. So we're using onboard encoding, which again does mean that occasionally we are going to have to not show the tests. Do take my word for it, it's all being done. You'll see afterwards, you can have a look at the timestamp if you choose. And of course, it does take a long time. So I'm going to take around about, I think I'm going to leave a 1 minute cooldown between each of these tests. So we should be back at least within the hour, but we'll see. But let's go ahead and run all of this myriad of tests here, and then I'll come back afterwards when the tests have been completed. Okay, so the test has completed. I'll start again. Okay, so our range of tests have completed, but before we go through those results, I should touch on a few things early doors. On the left-hand side of the screen, that is the official specifications for this SSD. As mentioned, in our testing of this device, the chances of hitting these numbers are pretty thin. To be honest, these have been tested on like a ridiculous 8-core systems, and again, as you can see, they're using a Ryzen 7 5800. As good as my processor is, there is no way it's going to be hitting that mark. Consequently, although my numbers are high and I'm quite pleased with them, they definitely did not hit here on these numbers displayed here on screen for this drive. The other thing I will say is temperature wise, another thing we were quite interested on for this test, that Blade heat shield. Gotta say, it did manage to keep the drive at the very highest point of some of our most kind of intense testing. It kept it at just over 60 at the highest. That was 62 C. But I will say it did maintain that heat did not dissipate as well as we've seen in other testing when we've looked at other drives and seen this thermal level drop quite significantly. The last thing I'm going to mention before we go through the results is the Adata toolbox. I should have mentioned this really in the intro. When we look at the Adata toolbox here, we're able to see a lot of real-time information about SSDs, but of course, once you go into more precise Adata SSDs, you can go ahead and update that firmware as needed, do optimization and more. And as you can see, if we check the firmware update, we are running this SSD on the latest version of that firmware there, for those of you that are curious. So, let's have a little look at those results. The first test we performed, probably the easiest to read there, Crystal Disk, and we went there with nice heavy sequential read-write and a bit of mixed at 7030, and as we can see, consistently it maxed into the 7000. It didn't hit that 7400 that the benchmark there was listed as, although that is on the highest capacity, of course, but still we are able to cross into the 6000s every time, even hitting as high as 6200 sequential write there, and the IOPS there lovely and high in the read IOPS as we expected, getting very close to the 1 mil mark at the 4K IOPS. Again, just shy of it there in the late 900,000s, and the write IOPS there living comfortably in the 5,000, just half mil mark all the way through, and the mixed results still been pretty consistent all the way through for this SSD in its default state. Again, if we have a little look through my records here at some of the older SSDs, we should have results on our early testing previously of when we bench tested the S70 non-Blade. As you can see there, in terms of temperature, when we are looking at the non-Blade drive there, you can see the difference that that heatsink has made. We can see there that when we go between the two of them, the highest that drive ever reached was maybe in the mid, maybe 55, 56C, with it comfortably living at the 40 to 50, whereas that heat shield there, certainly when it comes to the Blade model there without its chunkier heatsink, we can see that temperature there noticeably higher in idle between the two of them. Now again, if we take a little look, and we won't do this for each of them, but if we have a look about how things compared with regards to crystal disk, we can see that that additional heat shield there, if we compare the 1 gig test with the 1 gig test here, we can see that the numbers themselves ended up being higher on the one with the chunkier heatsink. We can certainly say, although there are some exceptions, a few little minor points, like a little bit of an extra spike there in terms of 4K write there on the Blade heat shield. Almost exclusively all tests were better, and indeed it cracked into the 1 million read IOPS, as well as better shared performance as well there with the fatter heatsink on the non-Blade model. So carrying on, we can leave crystal disk there and make our way into the next session of tests, which were of course Atto disk benchmarks. So there we have Atto there on screen. 3 tests at varying file size levels, just like before. So we got 256 megs, that's a quarter of a gig, 1 gig and 4 gig. And all the way through, we can see it was hitting that lovely consistent high, kind of late 5.6, 5.7 and even 5.8 gigabytes write, and with the read there again living in the 60s almost exclusively for the latter half of the testing in all of the arrangements there. Again, we're not going to hit the same performance as the sequential performance we saw earlier, and even if we go into the IOPS there, we can see that the IOs pretty good, but again we can see some areas where there's a little bit of inconsistency, but for the most part all living lovely and high on the 1 gig IOPS testing there, and again things differing slightly as we make our way through all of the tests there. And again we'll pick one, this time we'll pick the 4 gigabyte test. We'll switch back into here, we'll look at our 4 gigabyte test file there for read-write performance. So again, scale that up, have a look and see how these both compared. So again, in terms of read and write performance, once again we saw higher performance, particularly in write, but also in a number of read areas on that fatter heatsink there when we did our earlier testing on the Gammix non-Blade model. So if we come out of that there, we can make our way into our next barrage of testing there, and that was SSD. Again, 3 tests, 1, 3 and 5 gigabyte file sizes. And again, we can make our way, if we choose to, just to have it there in the background. This time we'll look at the 5 gigabyte test there on the non-Blade model. Bring that up there. And we can already see, again, SSD a little bit more of an aggressive tool when it comes to a lot of performance measures. But again, we did see that the 5 gig compared against the predecessor there, the Blade versus the non-Blade, again, higher performance with the fatter heatsink, unsurprisingly, but still, these are comfortable and expected numbers for those file sizes in SSD. We can even have a quick look at the IOPS as well and bring those up there on all 3 of them. Bring that, flick back to the IOPS and the 5 gig file, and again, we're seeing improved IOPS there all the way across the board from 16 meg to 4K on the fatter heatsink, but still nonetheless still comfortably sitting there in the 600,000 and the 700,000s at the advertised IOPS there by the manufacturers themselves. So again, comfortably within that margin at 1 TB. I'm quite pleased with it there. So finally, let's make our way into AJA. AJA, kind of a tough tool to utilize for measuring these performance benchmarks. Ideally, you shouldn't look at the big numbers. What we want to look at is the graphs at the bottom, because these give you some idea about the sustained performance. If there's a drop, if the cache isn't really keeping up, we're getting oversaturated there. But again, in terms of captures and playback or write reads, exactly what I would expect to see within this context. Again, ignore the big numbers at the top. None of those really apply to what we're seeing here. And again, just for the last time, this time we will look at, which one's this one? We're going to look at the 4GB test file there. We'll compare the 4GB test, and as we can see, the height there, very similar indeed, near enough identical, only a tiniest increase there on the non-Blade model, and that's because AJA tests are a great deal shorter but more impactful, something that means temperature spikes aren't really going to have the opportunity to really become a problem. But overall, looking at these performance benchmarks, the Blade doesn't reek of compromise. It's not a drive that I'm looking at there and wondering, is it going to be a lesser version than that of the fat heatsink and the non-Blade? I think it does stand on its own 2 feet. Yes, if you were to, put a gun to my head and ask me, go for the Blade or the non-Blade, I'd likely say go to the non-Blade one because of that chunkier, more effective heatsink. But I also know that it's not always going to be appropriate to PS5 installations, to more compact shuttle cases, and ultimately that giant heatsink may prove a hindrance for some, and the Blade version, with its improved NAND inside as well, as we mentioned in the intro, still makes it a solid drive. And if you see it on offer, snap it up. It's a great Innogrit controller SSD and definitely proves itself in our tests. So, that has been our review of the Adata XPG Gammix S70 Blade. There's a link in the description to the full review, which should be live by now, as well as a few comparison guides coming soon, both for PS5 and PC benchmarks, coming very, very soon too. Stay tuned for that. Click like if you enjoyed the video to help me understand what you guys enjoy and make the next one better than the last. And of course, take advantage of the free advice section over on NAS Compares, where we will help you and provide free data storage and network advice genuinely for free. We do nothing with your email. There's a donate button. Use it, ignore it. It's up to you. Otherwise, I will see you next time.